CMOS logic circuits. CMOS stands for complementary metal oxide semiconductor. Why the name complementary metal oxide semiconductor? As complementary is considered, in a CMOS circuit you are using both P-type and N-type transistor metal. Why the name metal is given? Gate of the transistor was made of aluminum metal in early days. Now it is made of polysilicon. As oxide is considered, silicon dioxide is the material between gate and channel. As semiconductor is considered, silicon is a semiconductor material used and it is a type 4 in the periodic chart. Hence the name CMOS. And in this the logic circuits are combined. That is, the logic circuits are designed with the help of CMOS. At the end of this class, you can able to explain the various CMOS design styles that can be used, and also you can able to apply the logic styles to combinational and sequential circuits. Introduction. A wide variety of CMOS circuits design styles have been developed to design high-speed VLSI networks. These styles are based on simple logic gates but operate in distinct ways. More advanced techniques have been developed to overcome one or more problems. Hence, based on the necessity, we can choose the various logic styles. The different logic styles that are available are mirror circuits, pseudo-NMOS, tri-state circuits, clocked CMOS, dynamic CMOS logic circuits, dual rail logic networks. These are the various logic styles that are in practice. In this class, mirror circuits and pseudo-NMOS circuits are going to be discussed. As mirror circuits are concerned, it is mainly preferred because of faster and more uniform layout. So as this circuit is considered, so this is the circuit for XR and it is especially a mirror circuit. Here it has an uniform structure for both PMOS and NMOS. Hence, in a layout we can able to achieve a uniform layout for both PMOS and NMOS. In this case, the output 0 implied that N-FET chain is conducting to the ground, and output 1 means that P-FET group provides support from power supply. Consider an example XR with A and B are inputs, and here if we consider the truth table, the various combinations are given here 0, 0, 0, 1, 1, 0 and 1, 1, and for the exclusive OR we can get 0, 1, 1, 0 as an output, and the ON devices for these combinations, so whenever there is an output 0, N-FET will be in ON condition, and whenever output is 1, P-FET will be in ON conditions. So this is what a mirror circuit basic operation, and the mirror circuit can be drawn as if we consider the exclusive or A exclusive or B, that is equal to AB bar plus A bar B, and it can be drawn in a PMOS with A, B bar. In PMOS it is in parallel and plus A bar B. These two are in series, and these A B bar and A bar B are in parallel connection with VDD, that is with PMOS. And if NMOS is considered, it is an equal to, that is it is equal to the exclusive NOR of NMOS. XOR PMOS is equal to exclusive NOR of NMOS in the mirror circuits. Hence exclusive NOR equation is A bar B bar plus AB. A bar B bar, these two are connected in series in NMOS, and the AB is connected in series in NMOS, and these two are connected in parallel in the NMOS, that is connected, and then it is connected to the ground. Based on the input given, the exclusive OR will provide an output. So this is what the mirror circuit is. The main advantage in this circuit is a similar layout. That is what the main advantage, and the faster outputs. So next is a pseudo-NMOS circuits. In the pseudo-NMOS circuits, the basic structure is PMOS is always connected to ground, and N-FET logic array is similar to the CMOS structure. Based on the input, the function output will be given, will be taken out. So here the main advantage is less number of transistors than CMOS, and for n inputs only n plus 1 FETs are required. For example, if we consider the basic operation, it is considered an inverter. Here always the PMOS is connected to ground, and here the NMOS, that is input is connected to VDD. So if input is connected to VDD, obviously the output is VOL, hence the NMOS is in conducting region. So it means that the PMOS is acting in a it means that the PMOS is acting in a saturated, P-FET will be acting in a saturation and N-FET will be operated in a non-saturation region. Hence the equation is, for P-FET it is beta P by 2 into VDD minus modulus of VTP whole square. So that is what for the P-FET, that is operated in a saturation region, and for N-FET it is operates in a non-saturation region, that is beta N by 2 into VDD minus VTN of VOL minus VOL whole square. As an inverter in a circuit, IDSN is equal to minus of IDSP. Hence these two can be equated, and then from this VOL can be computed, and that is equal to VDD minus VTN minus square root of VDD minus VTN whole square minus beta N by beta P into VDD minus VTP whole square. So hence we can able to design an pseudo-NMOS, and if we want to design pseudo-NMOS circuit for a given combinational circuits, so consider an example, a NOR and NAND2, that is 2 input NOR gate and 2 input NAND gate. The N structure, that is N-FET array structure, is similar to the CMOS structure for both NOR and NAND, and here the PMOS is always connected to ground. Hence in this circuit it is a smaller, simpler layouts, and interconnect is much simpler, and it is possible to resize in physical design. Thus from this class it is possible to explain the two CMOS circuits. One is the mirror circuit, another one is the pseudo-NMOS circuit, and based on the necessity the circuits can be chosen.